Yeah, okay, so we did the spray application, when I was with the, when I did my master's in plant pathology, and then also we did some research when I'm with Experico, so obviously the last 5 years we also did there some research. So I'm going to discuss some of the spray application research that we've done, and then also look at the assessment method that we're using. So the outline of the talk is to report back on work we've done on table grapes and on palm fruit, why the work was conducted and what was done, and then we will look at some conclusions. So as we know, there is a strong emphasis on chemical control of many diseases and pathogens, and here is just some examples of downy mildew on the leaves and the bunches there, the powdery mildew, and then also grey mold. These are pathogens that cause a lot of economical problems every year. Research show that fungicides are effective when they are tested in the laboratory. However, when these fungicides are applied in the field, we get every year there's several reported cases of poor control. Now the reasons for poor control can be either resistance, fungicide, pesticide resistance, a poor timing, a wrong dosage that was applied, or then the area that we are going to focus on is the inadequate spray deposition. Okay, so if you look at methods to improve deposition, we can look at adjuvants, optimal use of spray applicators, low volume or concentrated application, and then there can also be others. So we're going to first focus on adjuvants and then go on with that list. So we started with some of the research on the vineyards to improve deposition. If you look at the deposition assessment method that we are using is a fluorescent pigment that you put into the spray mixture, and that is then applied onto the target surface, the leaves or the fruit, and it can be illuminated then under UV light. So you can actually see it then under UV light, and you can take a photograph of this, or and then this image is sent into the computer, and software can detect then the remnants of the spray deposition droplets. Data, out of this you can get the data, and this is exported to MS Excel. So if we get back to adjuvants, here I just want to show what the effect of an adjuvant can be, more uniform dispersal of the droplets on that side. This is without the adjuvant, and that's with an adjuvant. Now the question is, why do you want this? Why do you want the better qualitative deposition? So we can move on to the next slide. This is basically botrytis that's germinating. You will see here that's on the outside of the droplet there. If you look at the hyphae lengths there and there, this is after 24 hours inoculation, and then if you see the same, this is also after 24 hours, and then the botrytis, you will see the hyphae is much shorter. That shows that the active ingredient in this droplets is working. This was done with only a fungicide, so there was active ingredient actually in the spray application. And the next slide is one where we use the adjuvant. So the spray droplets, the quality of the spray droplets was much better spread over the surface here, and you can also again see the hyphae lengths, it's much shorter. That there, it's spores that didn't make any hyphae, and this is a dead one over there. Okay, so we also went to the vineyard to test these adjuvants, but first we had to look at the optimum spray volume. We actually used the backpack mist blower, and we've seen that at 225 liter per hectare, the droplets is very small, and it gets bigger when you move to 900 liter per hectare. Here you can see the runoff over there. So we determined that 600 liters per hectare didn't give us any runoff, spray runoff. So we use the 600 liter per hectare to test the recommended dosage of different adjuvants. Okay, what you basically can see here is that all the adjuvants here, there's your Teldor, that's only your fungicide, and then your water, and when you put in a adjuvant, the qualitative deposition was better than on your upper leaves and your lower leaf surfaces. Okay, and then we asked the question, what spray volume, if you use different spray volume, what effect does that have on your adjuvants there? And you can see with the increase of spray volume, until 600 liters per hectare, you get good quantitative and qualitative deposition over there. But when you applied it at a higher spray volume, then you get runoff. That's for solitaire and agro. It's just a picture to show that. And then we also ask what is the effect of a different adjuvant dosages, and does it have an effect? And you can see here we use agro, new film P, solitaire, and villa, and you get better coverage with a higher dosage. But again, solitaire shows some runoff when the dosage was too high. Okay, so to conclude this, we can say that adjuvants does have the potential to improve quality of deposition and then the biological efficacy. However, we must look at this lower spray volume because you can get spray runoff. It's very important to match your adjuvant dosage and your application volume to achieve maximum deposition. Okay, and then we move to the palm orchard, and what we have looked at there was different applicator types, again at spray volume, droplet size, reduced energy, ground speed, and then also at the phenological stage. Okay, so in our first experiment, we looked at the SIMA, the ATASA, and then one was with a turret and without a turret, and the SIMA applicator, we did also add there a turret. Okay, that's just the pictures there. The SIMA and the ATASA with turrets, and then the ATASA applicator without the turret. And this was, the spray volume that we used there was then the high volume of 2,400 liters per hectare, and then the low volume of 600 liters per hectare. The positions in the tree that we took the samples from was the top, the center, and the bottom. And then also the outer and the inner part of the canopy. Basically, what we could see with all of the applicators was that the higher spray volume, we got a much larger droplets over there, and then you can see also the spray droplets running down there and also over there. And this was with the lower volume applications. The droplets is much smaller. The quality of deposition was quite good, and it covered a big part of the apple. Okay, so that's just a summation. Low volume resulted in better quality deposition than high volume at the top and the center of the tree and across applicator types. And then the applicator with the turret deposited more on the outer canopy than the SIMA with the turret. And then the ATASA without the turret deposited more in the center of the tree, in the outer canopy position than with the turret. So this, yeah, that makes sense. And then we also look at different droplet size at reduced energy. We included then the ATASA there with the standard droplet size over there, and then also the ATASA without the turret there also with small droplets. And this was tested with the reduced and then standard energy delivery. SIMA applicator was also included in this experiment. All applicators, we applied a low volume of 600 liters per hectare. Okay, what I want to show here is when you add a turret with the ATASA and with the SIMA, you always got better deposition quantity. So those over there and this one over here, all of these applicators without any turrets, the deposition quantity was poorer. Okay, on this table, it's just to show the there was an interaction between spray applicator, canopy depth and canopy height. Again, here I want to show that with the Ataza with the turret at the standard energy delivery setting, you will see here that this is actually the outer sides and then the inner side of the canopy, and that's the top fruit and the bottom fruit. You will see it's the same over there and the same over there, but with the standard with this one there, you will see on the outside of the top fruit there was better deposition over there compared to there, and that one there compared to that one there. Okay, and then here again you can see there's not, if you look at the different positions here, you can see that with the standard and the small droplets there wasn't, if you look at the specific position, there wasn't much differences over there and over on that side. So you can say that between the standard droplets and then the smaller droplets, didn't make any difference. And then the CMA applicator performed a little bit better than all the other Ataza applicators with or without the turret. Yeah, and I think that one there on the outer fruit, yeah, the bottom fruit was similar than that one there. Okay, so deposition improved by the using the Ataza or the CMA applicator with the turret, and the deposition was generally better with the CMA with the turret than the Ataza application on fruit. Deposition quantity was not affected by droplet size, and deposition only affected by the energy delivery using the Ataza with the turret. Higher quantitative deposition was recorded with the standard, then a reduced energy in the top of the canopy and on the inner and outer fruit. Okay. So if we look at energy delivery and then at the ground speed, you will see this is basically the Ataza plus the turret, and that one too. Energy delivery is the same, but ground speed is different. This wasn't a statistical difference over there and over there on the outer and the inner leaves, but you can see there's a trend of higher deposition over there and there. There and there. Okay, and if you look there, you can see that with the standard and the high energy delivery over there, same speed, the deposition was better with the standard than with the higher energy. Deposition quantity was affected by the applicator type, delivery energy, but to a lesser extent by the ground speed on leaves and fruit. The standard energy delivery generally was better to ensure a quantitative deposition. The negative result was most likely due to the deposition that was blown away from the target surface by the higher energy delivery. Okay, and then we also we did some research where there was questions what the electrostatic sprayer can do, and we used the KWH or the Matignani. It's basically the same applicator, and we compared that with the Ataza with the turret and the CMA with the turret, and that one over there was done then at the ground speed of 3.8, and then 600, more or less 600 liters per hectare, and over there the same. And then the electrostatic sprayer was done at the speed of 5 km per hour, and then at the volume of about 300 liters per hectare. What we found there was that the KWH performed similar to the Ataza and the CMA applicator technology types. Deposition was often higher for the CMA compared to the Ataza spray system, and applicators were generally deposited significantly more pigment to the outer than the inner, and the top than the bottom canopy positions. We also look at the phenological stage. And what you can see on this picture is that the deposition over there there was basically two phenological stages. This was the one and that was the second one. And the deposition, when we applied the second time, was much more than the first time. And so basically we didn't see any run-up at the earlier phenological stage. And it's likely that the spray is blown through the canopy at the early phenological stage without affixing to the fruit or the leaves, and then critical waxes are also known to change during the phenological development, which may influence the deposition to the surfaces. If we do a general conclusion, we can see there's various parameters that can affect deposition on an active ingredient on the target surface. And the way forward here, we say that more research is required to improve the use of different application technologies to enhance these disease and pest management on horticultural crops. A tool for measuring the output and effectiveness of spray deposition is being developed, and this tool may in the future assist producers to quantify and qualify the deposition of spray material and hence the efficacy of disease and pest management. Thank you.